Right, we are simplifying rational expressions. The word rational just means that we're looking at a fraction. We have a numerator, we have a denominator. When you are canceling or simplifying, you need identical factors. If they're just numbers, like 18x to the 6th divided by 27x cubed, those are considered monomials, one term, there's no plus or minus between them, they're all connected, then all we have to do is just kind of simplify it like we've been doing our power rules. Where are there more x's and how many more? So that's as simple as 3 more x's on the top. What about the numbers? They don't follow the power rules. I just need to reduce this. And if you're not comfortable with reducing, again, we have these beautiful instruments called calculators that can make your life a lot easier. And I heard some people already say the correct answer is yes, 2/3. But if you're not sure how to reduce that, put it in as a fraction on your calculator and hit equal, and it'll give you what goes on the top and what goes on the bottom. The only time you're going to come into maybe a little bit of a problem is if it's a mixed number, and then you'll have to convert it to improper, because we don't want to put the mixed number into the problem. But that gives me 2 on the top and 3 on the bottom. So monomials, no pluses and minuses, life is pretty good. But when it comes to trinomials, binomials, bigger polynomials, then we run into a little bit of a problem. I cannot work with this 6x and this 3x because it's part of a bigger thing. So what I need to do, this is where our factoring comes into play, what I need to do is break down the top and break down the bottom as much as I can. I love it when there's no number in front of the x squared or the squared term, because then I can do a real quick shortcut factoring. I need to find 2 numbers that multiply to be 8, add to be 6, 4 and 2. So my breakdown is x plus 4, x plus 2. Factored pretty quickly, all right? I write this down just because it's a visual, but usually this just goes on in my brain, right? So you don't necessarily need to write that down. Those of you who are guessing checkers, you probably do that already. The bottom doesn't have a squared in it, but that does not mean it can't be factored. I can pull a 3 out of both terms. That's the greatest common factor, and I don't ever want to forget that. All right? Now I look for identical quantities. Pluses and minuses screw things up. I need to make sure that if I have pluses and minuses, that I am canceling out the entire quantity that matches. And in this case, that's the x plus 4, x plus 4. So that's simplifying a rational expression. That leaves me with x plus 2/3, final answer there. All right? So please watch out, because again, I can say this over and over and over and over and over again, and there are still people that in this next problem, in problem number 3, they're going to see k squared and cancel it out right away. It's going to happen to at least one of you. Don't let it be you, okay? So number 3, pluses and minuses. Change things. This is k squared minus 7k plus 12. Because there's nothing in front of the k squared, I can do a quick in my brain. 2 numbers that multiply to be positive 12, add to be negative 7. Negative 4, negative 3. Remember, a negative times a negative is a positive, a negative plus a negative is a bigger negative. So this on the top is k minus 4, k minus 3. I'll do the same thing on the bottom. Also, nothing in front of the squared term, so I need two numbers that multiply to be negative 15, add to be positive 2. That means one of the numbers has to be negative and the other one has to be positive. And I know that because that's the only way I'm going to get a negative product. Remember, it's multiply to the top, add to the bottom. And I also know that the bigger number has to be the positive one because that's the only way I'm going to add a negative and a positive and end up with a positive result. And what works for me is 3 and 5. So this is k minus 3, k plus 5. Once I factor both of them, now I can look for my identical quantities. K minus 3, k minus 3. And k minus 4 over k plus 5 is my final answer. Simplifying. Now we're going to get into multiplying and dividing. Multiplying and dividing are nice. We don't need common denominators when we multiply and divide fractions. Even if it has all the letters and garbage in it, we still do not need a common denominator when we multiply or divide fractions. So all I need to do is break them down and start canceling things off. If there's something on the top and something on the bottom that are identical, they can go. Again, be careful. X squared and x squared cannot be canceled if they are followed by a plus or a minus. I will say it over and over and over again. I want to factor these things. So the x plus 3 will stand alone. I will factor the denominator of the first, the numerator of the second, and the denominator of the second. How's our factoring feeling? Anybody think they can factor the denominator of the first pretty easily? Jonathan, what'd you get? X minus 2. X minus 2, x minus 2. X minus 2, x minus 2. We're looking for two numbers that multiply to be positive 4, add to be negative 4. That's negative 2 and negative 2. How about the next one? Numerator. Anybody got that one? Luke? X minus 2, x plus 1. Again, so if we do a visual, I need two numbers that multiply to be the end number, negative 2, add to be the middle number, negative 1. Looks like I need a negative and a positive to get a negative product, and the bigger number has to be the negative 1 to get a negative sum. So we get x minus 2, x plus 1. How about the bottom one? Yeah. X plus 1, x plus 3. Again, if I do a visual on that, two numbers that multiply to be 3, add to be 4. 1 and 3 fit the bill pretty nicely. Good? Okay. Oops, except for you can't see my visual. Visuals don't help if you can't see them, do they? All right, then I just look, top and bottom. It can be in the same fraction, like when we were just simplifying. It can be in opposite fractions. Just top and bottom cancel. I see an x minus 2, x minus 2. This is so gratifying to me when I cross things off. I don't know why. X plus 1, x plus 1. X plus 3, x plus 3. What happens when I cross off everything from a level? I replace it with 1. So everything on the top got canceled. That means that beautiful factor of 1 will remain. And the only thing left is x minus 2 on the bottom. All right? We feel okay, right? Everything looks good. Yeah.
I think I'm missing a page. Look at the one.
Oh, did you not grab these at the beginning like I asked you to replace them? You had to rip off the, yeah. Sorry about that. I'll give you the notes. Just continue with us right now. And then the homework too. There was another homework page that you had to rip off. Okay. Anyways, are we good so far? Feeling it? Feeling groovy? Any questions? All right. So sometimes we feel good, and then all of a sudden we see a problem like 5 and we panic. What is going on here? Fractions in fractions, exactly. So I have x squared minus x minus 12 divided by 3x plus 9, and that whole thing is divided by x squared plus x plus 20 divided by x plus 5. And so what I'm going to do is just rewrite this. Yeah. Okay, how so?
I did it in x squared plus x plus 20 plus 2.
Oh, okay,
And I think something we know.
okay,
Yeah.
okay,
Okay.
okay. All right. Well, let's start going. This is x squared minus x minus 12 over 3x plus 9 divided by x squared plus x plus 20 over x plus 5. We do not divide by fractions, right? What do? Flip and multiply. So I flip the second and multiply. So I have x squared minus x minus 12 over 3x plus 9 times x plus 5 over x squared plus x plus 20, and then I start to factor. Can I factor the numerator of the first fraction? Yes. It breaks down into x minus 4, x plus 3. Can I break down the denominator of the first fraction? Okay, what do I get? What is it? Take out the 3, so it's 3x plus 3. All right. Can I factor the numerator of the second fraction? No. Can I factor the denominator of the second fraction? No, we already determined that. No. X squared plus x plus 20. All right? In a perfect world, things will cancel out. In a not so perfect world, they won't. And so there are times when I'm not going to find the identical quantities that I'm looking for. Don't force it to be something that it's not. Make sure you factor properly and cross off what you can. All I can cross off is the x plus 3. What does that leave me for my answer? X minus 4, x plus 5 over 3 times x squared plus x plus 20. Or x squared plus x minus 20 over 3 times x squared plus x plus 20. Oops, I forgot my parenthesis. I'm running out of room. I wrote too big. Didn't leave enough space. But there are going to be occasions when your answer is not nice. You cannot cross off this x squared and this x squared. You cannot cross off the x and the x. You cannot cross off the negative 20 and the positive 20 and make it negative 1. Not allowed. This is where we have to stop. There's nowhere else we can go. Okay? So do not cross things out that are separated by plus or minuses unless they are identical quantities. All right, our last one on division. Looks like most of you are feeling pretty comfy doing it, right? Not so bad. Please do not forget your GCF. So number 6, is there anything I can, or is there any way that I can factor, I was doing cancel and factor at the same time. Factor the top. What can I take out? 8n. Do not forget your GCF. 8n. So this is 7n plus 1 over 8n times, I'm going to flip and multiply right away, n over, n minus 3 over, how about the next one? What can I take out? 5n squared times 7n plus 1. Okay, great. Can I factor the 8n now? I couldn't factor the x squared. Is it okay to factor the 8n? Or cancel out? Yeah, why? It's not followed by what? A plus or a minus. So the 8n's can go. Gone, gone. The 7n's can go. How about these n's? Well, the bottom one's not followed by a plus or a minus. Still can't because the top one is. So I'm down to n minus 3 over 5n squared. Multiplying and dividing rational numbers, even when algebra is involved, I think isn't bad. As long as you can factor, things clean up usually pretty nicely. If they don't, like in number 5, there's not much else we can do. All right? Adding and subtracting can be a different story. And so that's what we're going to end with, adding and subtracting. You have to have a common denominator. There is no rule in the world that says it has to be the least common denominator. It's just that your life is going to be easier if it is. Okay? You can find any common denominator, and in general, the easiest way to find a common denominator is to just multiply the first fraction top and bottom by the denominator of the second, and multiply the second fraction top and bottom by the denominator of the first. Then you're guaranteed a common denominator, but it's not necessarily the least common denominator. And if you do it that way, you're going to end up sometimes having to cancel in the end. So if you can find the least common denominator, that's a better route. And the least common denominator is the factor that they share. So for problem number 7, the first fraction has 8. The second fraction has 8x in the denominator, and so the first fraction is only missing that factor of x. So I'll multiply the front fraction top and bottom by x, leaving me with 5x over 8x minus 3 over 8x. And then when I combine them, the best I can do is 5x minus 3 over 8x. I just put them over their one common denominator. That's why we found that. Can I cancel these x's? No. Still the same thing. Rules still apply the same way. Cannot do it. So this is it for that one. Now that was super nice, right? Really nice and easy. All I did was multiply an x by that first fraction. No big deal. So then I should probably just be able to add an x to this first fraction. No. Math has all the rules we have to follow. This is a quantity, and that quantity, because it's separated by a plus, the 8 and the x, they are together as one grouping, and that means that I need to have an 8 plus x in the first fraction, and an 8 by itself in the second fraction. This 8 is not covered here. This is a single factor of 8. This is a factor of 8 plus x. They are two very different things. So I will multiply the first fraction top and bottom by the 8 plus x. And I will multiply the second fraction top and bottom by the 8. So what I'm left with here is 5 times 8 plus x over 8 times 8 plus x minus 3 times 8 over 8 times 8 plus x. What gets confusing a lot of times in math is it seems like the rules are changing. Like sometimes I can just multiply the x in, and sometimes I have to do the whole thing. And sometimes I'm gonna simplify and multiply through, and sometimes I'm not, so I'm gonna throw another one at you. When it comes to combining these fractions, I do not need to do anything with the denominator once I find the common denominator. You can, you just don't need to. I do need to clean up the top though, because that's the part that's going to combine together. So I get 40 plus 5x, and then I'm going to do this like middle school trick, plus -3. So then I end up with a plus -24 or -24. Which leaves me with 16 plus 5x over 8 times 8 plus x. Can I simplify the 16 and the 8? I see some head shakes. No. Why not? The 16 is followed by a plus. The 8 is not. I've got to stop here. Any questions on that one? Okay, moving on. Again, the easiest way to find a common denominator is to multiply the first fraction numerator and denominator by the denominator of the second, second by the denominator of the first. Again, that doesn't always mean it's the least common denominator, but it is a way to simplify it. I'm trying to find the perfect pen. How about red? Okay. So, n minus 4, n minus 4, n minus 6, n minus 6. I'll distribute that through 2 times n minus 4 over n minus 4, n minus 6, plus 2n times n minus 6 over n minus 4, n minus 6. Now, I want to stop and talk about this for a little bit. We're talking about simplifying and canceling out. And so a lot of times when we're working, we get to this point and we say, oh boy, I see an n minus 4. I'm sure you guys say it like that, right? Oh boy, I see an n minus 4 on the top and on the bottom. I'm going to go ahead and cancel those out. Except you're ruining what you just accomplished by getting rid of the piece that you multiplied in. So again, I'm mentioning it because it's something that I see happen. When you're adding and subtracting, you've got to turn your brain a different way. And now I need to clean this up once I find my common denominator. 2n minus 8 plus 2n squared minus 12n all over my common denominator, n minus 4, n minus 6. Then I'll move my stuff around. This is 2n squared minus 10n minus 8 over n minus 4, n minus 6. I've been writing way too big. I need to calm down. Then I'm going to move this over and factor out what I can on the top. 2 times n squared minus 5n minus 4 over n minus 4, n minus 6. And then I want to see if I can factor. So on top, I'm looking for two numbers that multiply to be -4 and to be -5. Again, a visual here. Two numbers that multiply to be -4, add to be -5. Try as you might. Not going to happen. So I'll have to stop here. If it does happen, super fantastic. If it doesn't, then it doesn't. All right, so moving on here. I'm going to talk about that least common denominator again. You do not have to find the least common denominator. It is not the law. However, if you do, it can make your life easier. Instead of multiplying the top and the bottom by 2x minus 6 on the left and the top and the bottom on the right by 2, what I'm going to do is factor the second one here, pulling out the greatest common factor, and then the only thing I'm missing in this first fraction is the x minus 3. 2 is covered. Okay? If you miss that, no big whoop, you're just going to have to simplify in the end. But I'm going to do x minus 3, x minus 3. That's finding the least common denominator. So 3 times x minus 3 over 2 times x minus 3 minus x minus 4 over 2 times x minus 3. Please watch out for the minus, especially when there is a quantity. Again, another thing that I see happen often. People just bring the minus up to the x and they don't bring it throughout that whole thing. It's the opposite of the whole thing. So we'll do that again, that middle school trick that we did, plus negative, and then I want to make sure that I distribute that negative throughout. Okay? So this is going to be 3x minus 9 minus x plus 4 all over 2 times x minus 3, because I do not have to do anything with the denominator. Again, the minus that I had there went through to the 4. And then I'll move this over here. 3x minus x, 2x, negative 9 plus 4 minus 5 over 2 times x minus 3. Can I cancel out the 2's? Down to the last 2, and they're both kind of the same, all right? On the last 2, the only difference is we have one fraction and either 1 or 2 non-fraction things. No sweat. I can make it look like a fraction. I can make any number look like a fraction by putting it over. Exactly. So that's what I'm going to do. I'll put the 2 over 1. And then my common denominator is just simply that p plus 8. So I'll multiply the top and the bottom here by p plus 8. And I have p minus 3 over p plus 8 minus 2 times p plus 8 over p plus 8. Don't cross off the p plus 8. I'm going to, if I do that, if I cancel this out right here, I'm going to undo the progress I made. I need to clean this up and multiply it through. I want to get it together over the p plus 8. So I'm going to go back to middle school, do my plus negative. Don't forget that. Don't. This is p minus 3 minus 2p minus 16 all over p plus 8, or negative p minus 19 over p plus 8. Or, if I'm feeling fancy, today, I can take a negative out of the top, and I can write it as the opposite of p plus 19 over p plus 8. That would be a final answer on that one. What if on your homework you didn't do this? No big deal. I show you because we will take multiple choice tests. And if you don't get an answer that you find in the selection, sometimes it has something to do with a negative that hasn't been factored out. Okay? So just keep an eye on that stuff. Okie doke. Last one. The a plus 1. I could put the a over 1 and the 1 over 1 and have two separate fractions. Or I can do it all in one big lump and put that whole quantity over 1. If I put the a over 1 and the 1 over 1, I'm going to have to multiply them both by the a plus 4 and distribute those pieces through and then combine the three fractions. If I do the chunk here, I'll just end up with two binomials that need to be multiplied together. And it ends up being the same thing, okay? So I'm going to multiply top and bottom by a plus 4. That leaves me with a plus 4 times a plus 1 over a plus 4 minus 5a plus 4 over a plus 4. Remembering that 5a plus 4 is a quantity, it's together, it's got a plus between it, so there are parentheses around it. So when I take a trip back to middle school and do my plus negative, I have to distribute that minus through to both parts. All right, so I have a squared plus a plus 4a plus 4 plus negative 5a, minus 4. I don't know why I wrote plus negative 5a. I'm not going to on my next one. I'll clean that up. And then that's all over a plus 4. So it looks like I have a squared. This is 1 plus 4, 5, minus 5 gone. 4 minus 4 gone, over a plus 4. Can I cancel out an a? No. Again, same thing, plus between it. I love that some of you are still responding to me. I appreciate that, thank you. All right. Any questions on this? Any concerns? How do we feel? Pretty good? Okay. You'll talk to me later, whatever. Okay. Homework, last section. 1-4.